17 is a three-part question that asks us to find the velocity past the equilibrium point, the velocity when it is 0.10 meters from equilibrium, and C, the total energy of the system. Over here I wrote down our energy equation as well as our equation to find K and our givens. To solve for A, which I will be doing in black, which is asking us to find the velocity when it passes the equilibrium point, we will use 1/2 Ka squared equals 1/2 mv max squared. However, we got to find K first, so we're going to use this equation. So we fill that in. We'll do that over here. K equals 0.6 times 2 pi 3, which is all squared. And once you do that out, you get 213.18. That's K. So then we plug that into 1/2 Ka squared equals 1/2 V max squared. So we write that down over here. 1/2 K being 213.18 times our amplitude squared, which is 0.13, equals 1/2 of 0.6, which is our mass, and V max squared, which is what we are trying to solve for. And once we do out all the math, V max equals 2.5 meters per second. And that is A. On to part B. Part B asks us to find the velocity when it is 0.10 meters from equilibrium. So we will use 1/2 Ka squared equals 1/2 mv squared plus 1/2 Kx squared. So let's write those numbers down. 1/2 times 213.18, which again is our K, times 0.13 squared, which is our amplitude, equals 1/2 times 0.6, our mass, V squared, which is what we're looking for, plus 1/2 213, once again our K, which is 0.18, 213.18 times 0.1 squared. And we do all that math out, and we're left with V, which equals 1.6 meters per second. So the answer to B is 1.6 meters per second. On to part C finally. Part C is asking us for the total energy of the system, so that is simply the equation E equals 1/2 Ka squared. So we just fill in the numbers here. E equals 1/2 times 213.18 being our K times 0.13, our amplitude squared, and you do that math and it comes out to be 1.8 joules. So the answer to C is 1.8 joules.